you doing today? It's been a long conference. I'm the last talk of the day. I hope you're all freshen up. Who here is their first Node conference? Cool. My name is Doron Tsur. This is my Twitter handle. You're more than welcome to hit me up after the conference. I have two lovely girls that don't care at all about what we're doing here, but they're great, so they get mentioned. I work at an AI company which creates a vibe coding tool to create web application, and I've been using Node.js from 0, 10, 12, or something like that. And I want to start with a story. Once upon a time, a few years back, I was working on a problem. I basically had service A, which was a very I/O-intensive service, and it would send information to service B, very normal situation. And that service, in turn, would overwhelm service B. Service B was a CPU-intensive service, and the I/O service would just send too many requests and would make it choke and crash. And so we figured what to do in the team, and we kind of thought about it, and we figured, let's use a service mesh. Now, for those of you who don't know, a service mesh is an infrastructure layer placed in order to facilitate communication between different services. So, for various reasons, we decided to roll our own service mesh. I won't get into it in the scope of this talk, because it's a long talk of its own. So we have service A, and every service in the service mesh has a sidecar. So it sends all the traffic to that sidecar, and that in turn sends it to an orchestrator layer. So it sends it to an orchestrator, and service B has its own sidecar, and it pulls all the information from there, and it can send it in a controlled way to service B. So that way, we kind of solved our problem. Service A is not overwhelming service B, and we can control the traffic, order it, make sure that all the communication is fair among tenants. And then I started thinking with the team, what's going to be the testing strategies? And as we all know, there's a few testing strategies. By the way, who's seen the testing pyramid before? Okay. And so the testing pyramid is a way to think of our test. We have at the bottom unit test, and as we go up, we have less and less tests. The upper layers are meant there to support less tests, and the more up we go, we have broader tests that cover more components and which are hard to debug, hard to maintain, and sometimes are flaky. And the lower we go, we get to unit tests, and they basically are more focused, isolated, and they cover pieces of code well. Who here is a die-hard unit tester? Any unit tester? Well, unit tests are great, and they give you an interesting sense of security. But sometimes when you write and when you focus a lot on unit tests, you reach a situation where you have assurance that each component on its own works, but together they don't work well. And in this case, I want to focus on integration tests. Now let's define integration test. An integration test is basically the practice of finding defects between interfaces of different components in the system. In our case, we have a lot of moving parts. We have the sidecar, which is developed by myself. And we have service A, which is developed by another team. And the orchestrator was developed by a different team member on my team. So we have all these moving parts. We want to test them. And the entire idea of service mesh is basically to facilitate the communication of services. It's all about integration tests. So we have integration tests. That's probably our main focus for this subsystem. And Docker comes to mind. I have other pieces of code, services, which I want to run, and then I want to get them, in isolation. I get a fresh environment every time and make sure they're isolated. I can basically treat the other components in the system as a black box and not care about internal implementation or anything of that sort. And when you think about Docker, a natural progression from there is to use Docker Compose. Docker Compose is a useful tool which helps you describe in a declarative way all the components you want in a specific setup, and then you can bring it up, run your test, and bring it down. It's a very common practice when you do testing. Problem is that normally parallel execution in the area of Docker Compose is cumbersome. You bring up partial parts of the system, or you want to basically have a few Docker Compose files. Doesn't work that well. And we want different setups, probably. In a single Docker Compose file, we can describe a specific setup. Multiple files is a bit too much. So the solution was, and it worked well, just take Docker, have a few Golang functions. I know this is a Node.js conference, but I was writing Go at the time, and trying to basically run Docker container. Everything runs in parallel. It's a function coming from the code. Works well. Few years pass, and I have a job at a client. I did, in the past years, some consultancy work, and basically, we had a classic problem. We had a service and a database, and the service needed to create queries dynamically. The service would scan the database, look at its internal structure of the tables, and basically see how to manage the queries. And because I wanted that deep integration with the database, I thought to myself, okay, this seems similar to what I encountered a few years back. Let's bring the Docker, start to write my functions, and see what we can do. But before that, I wanted to look, what are the different strategies out there to do database testing? And one of them, probably not in your JS shop, is a shared database. Somewhere in the system, you have a shared database. Normally, because getting the data to your local testing environment is hard to get, you run your test against that. It's very simple to set up, but it has internal state which can collide with other developers, meaning you can interfere with other people running their tests. Another option is Docker Compose. It's isolated, gives you what you want, but we just discussed the issues with Docker Compose. It's complex, can be slow, and doesn't really cater to all our needs of parallel execution, running really fast and stuff like that. Another common option is in-memory database. I can load up a database, attach it to my memory, and basically work as if I'm working with a real database. It's fast and efficient, but the problem is it kind of gives you false confidence. And then you kind of feel like your test suite passes, but maybe the queries don't work against the real database. And the last option is the mocking. You basically take your data access layer, mock the responses from the database as if the function returns successfully. It's even faster than the in-memory option, but the problem is still it kind of gives you false confidence because you don't know if it works in a real deal. And I was looking at all these options, and I didn't like them. And I remember the project I did a few years back, and I figured I'll probably need to do the same thing again. Just take Docker, run it, kind of like do exec and stuff like that, and have my configuration from a few functions. But I was lazy. And sometimes being lazy was good. I was thinking to myself, it couldn't be that other people haven't encountered this issue. So I started searching online, and I encountered this library called TestContainer. TestContainer is a library by Atomic Jar, which was a few years back purchased by Docker. And they basically give you a programmatic interface into Docker. You can configure, run things in parallel, control it from the code, exactly what I wanted. Actually, if I've known that before, I would have probably saved myself about a week in the pre-AI era, and save the time for the company I was working for. And we're a Node.js shop, and TestContainers support Node.js, and also supports a bunch of languages. So if you're in your shop, you're like a poly programming kind of place, then you can find your favorite language there. Sorry. Okay. So one of the basic offering of TestContainer is the generic container. You basically can specify which Docker you want to run, pass in the environment variable, tell it which internal ports to expose, have this waiting strategy going on, so basically you can wait for the database to be ready. Sometimes when you're doing integration tests, flakiness comes that you either run your test too early or run it too late, and then it costs you time in the test. And that's a lovely way, and anything from a Docker file, your service, message brokers, database, Elasticsearch, Postgres, whatever you can think of, you can run with TestContainers. But TestContainers also give you a bunch of pre-made modules, basically modules that you can use which are already pre-made and with some ergonomics and niceties that you can use. For example, the same generic container we used before to run Postgres can be used with the Postgres SQL container. I pass in the version, username, password, and database name, and I also say to wait for a timeout. Now notice I didn't need to basically expose the port because it's pre-configured. They know it's the internal port, and it works well. And after we configured the container, it raises up, and you can basically run your test against it. We can then query the container objects that get all the information we need from there. That way, we don't get a problem of port collision when we want to run multiple containers in parallel, and we can get in the code the port, all the data of that database. And we have now a PG pool client. We can connect to it, run our test. And after that, we probably want to build our test. Usually, you might run your migrations here. You might run some snapshots you want to load into the database. And that's where you get your own container with a state which is specific to your suite in your local and in your CI environment. Here, I just did a contrived example to create a table and to create a basic user just to show you what's the process. When the test is over, we call container stops. It brings down the container. And a little tip from me. So you have a decision to make sometimes where to set up the container, either in the before all or the before each. If you do it before all, the container is shared between the suite. If you do it before each test suite, a container will be brought up. That's very useful. I've seen setup where we have hundreds of Docker container running, and it runs smoothly and perfectly. Perhaps it's my good Mac, I'm not sure, but I recommend before each, and only if you encounter some kind of a performance issue, then go for the before all. Now for a little tiny demo, I just wanted to show you that I've been using it for the past 2 years, both in consultancy and also at my current job. So I have here a while true. It just prints docker ps -a. It basically shows you that what's the running containers. I don't have any running containers. And now I'm going to run my test. Notice if you've been to Gil's lecture, it's no emit because we're using an advanced node. And just in a second, you're going to see the containers coming up and going down. The last container staying there is basically this like maintenance container, but making sure that you don't have leaking resources of some kind. And just for good measure, I'll run it again to show you. And you have a few Postgres containers running for each script. By the way, this is a real service we have in production. I'm actually in the middle of a branch, and we have those containers running in parallel. So, just to summarize a bit, we've seen a complex example in the beginning where we have a setup where you need to bring up different services and work hard on the integration test. Test containers, have I known it at the time, would save me time and would probably use it, and it solves all the problem, the complexity of hard integrations. We've also seen a classic problem where we have a database and a service, and we want to test against the real database and real tests that actually test that. If you encounter an integration problem, I highly recommend using test containers. And thank you. That's what I have for you today.